Campfires look nice and it demonstrates some interesting chemical changes. When you sit around the fire, you feel the heat on your face because the energy is being released to the surroundings. Most is heat and some is light, and your face is part of the surroundings. For example, fuels release large quantities of heat when reacted with oxygen. This is an example of an exothermic reaction. So why does this happen? We have to look at two underlying principles in chemical reactions. 1. Energy is required to break bonds, and 2. Energy is released when new bonds are formed. Think of those molymod kits. It's much easier to build the molecules in comparison to pulling them apart. So for example, when you place a magnesium strip into hydrochloric acid, it produces a magnesium chloride and hydrogen gas. However, before the magnesium is able to react with the hydrochloric acid, the particles that make up your magnesium strip are held together tightly, and for them to be rearranged and interact with the hydrochloric acid, it will require some energy to pull it apart. Then when magnesium chloride and hydrogen gas are produced, energy is released when these new bonds are formed. So when comparing the amount of energy needed or absorbed to initially break the bonds in the reactants versus the amount of energy released when the new bonds are formed, this determines the type of chemical reaction. And since the average bond energy, which is the energy required to pull particular atoms apart measured in kilojoules per mole, they all differ depending on what atoms are joined, and this will ultimately determine whether more energy is released or absorbed. As such, in exothermic reactions, more energy is released when the new bonds are formed in comparison to the energy needed to break the initial bonds. This is why the surroundings feel warm. And in an endothermic reaction, more energy is absorbed to break the initial bonds and less is released when the new bonds are formed. This is why the surroundings feel cold.